In this video, we're going to talk about integration using tabular method. Tabular method, you could think of it as a shortcut of doing the integration by parts, but you have a limitation. I will explain about the limitation of tabular method as I do examples. So let's say you want to take the integral of x squared e to the x dx. Using the limit LIPT, there is no natural log, there is no inverse trig, and there is a polynomial, which is x squared. So our u is going to be x squared, and dv is going to be e to the x. You could put dx if you want. So here, what we're going to do is we're going to make a table. So u, put u and dv. So it's x squared and it's e to the x. Okay, for tabular method, you don't have to worry about dx. So now what you need to do on this column is that you need to keep taking the derivative until you get 0. And here, you will take the antiderivative. So what's the derivative of x squared? It's 2x. What's the derivative of 2x? 2. What's the derivative of 2? 0. On this column, we're going to take the antiderivative. So antiderivative of e to the x is e to the x, e to the x, e to the x. Now, what you need to do is you need to draw arrow from the first term of u to the second term of dv. Second term of u to third term. And you repeat this process until you get to the last term of dv. And you have to put sign, starting with positive. Positive, negative, positive. So the answer to this example right here will be x squared times e to the x times positive, which is x squared e to the x. And 2x times e to the x times negative, which is negative 2x e to the x. And then 2 times e to the x times positive. So positive 2 e to the x. And then at the end, you put plus c. So this will be the answer. Now, of course, you could use the formula that u dv equals uv minus integral of v du. You can use that too. But if you use this formula for this problem, it'll take much longer. So tabular method is much easier. You save a lot of time. The only limitation is if you want to use tabular method, whatever you let u equal to, you need to be able to find the derivative so that at the end it ends up with 0. If you're not able to do that, then tabular method will not work. Let me show you another example. So now you got integral of x cubed sine x dx. So what is your u going to be? X cubed. And dv is going to be sine x dx. So let's make a table. Because we could do that. We could use a tabular method. Because if you keep taking the derivative of x cubed, you will eventually end up with 0. So u dv x cubed and sine x. What's the derivative of x cubed? It's 3x squared. Derivative of 3x squared, 6x. Derivative of 6x is 6, and then it's 0. Now here you got to take the antiderivative. What's the antiderivative of sine x? It's negative cosine x. What's the antiderivative of negative cosine x? negative sine x. And then negative, antiderivative of negative sine x is cosine x. And what's the antiderivative of cosine x? Sine x. Now we have to draw the line. Then don't forget the sign. Start with positive, negative, positive, negative. So your answer will be x cubed times negative cosine x times positive, which is negative x cubed cosine x. And then it's going to be 3x squared times negative sine x times negative. So positive 3x squared sine x. 6x times cosine x times positive. So positive 6x cosine x. 6 times sine x times negative. So negative 6 sine x. And don't forget plus c. So this will be your final answer. If you were to do the integral using the formula, and it will take a lot of time.